I welcome you once again into this revision platform. I hope by now you must have invited some of your friends around to join you. I still remain your mathematics teacher, Mrs. Clara Namsi Samuel. And today's topic is matrices, as in plural, singular, matrix. Now, what are metrics? Let me put it in singular. Matrix is simply a set of numbers that is arranged in rows and columns to form a rectangular array. What did I say? A set of numbers arranged in rows and columns to form a rectangular array. Examples of matrices include a 2x2 matrix, a 3x2 matrix, a 2x3 matrix, 3x3 matrix, and 4x4 matrix. 2x2 matrix simply means 2 rows and 2 columns. The first number represents the rows, while the second represents our column. Okay, let us list out some of the matrices that falls within this. Let's begin with a 2x2 matrix. Take for instance, A is giving us 3, 1, 4, 5. 3, 4, 1, 5. This matrix is simply arranged in 2 rows. The first row is this. The second row is this. And it's also arranged in 2 columns. The first column is this. The second one is this. So that is why we have 2 rows, 2 columns. This is what we call 2x2 matrix. A 3x3 matrix is also written as 3, 1, 2, 4, 8, 1, 0, 2, 5. Sorry, this should have been 2x3 matrix. 2 rows, 3 columns, because there is no how we can have 3 rows and 2 columns. Okay, so the third one is the 3x3 matrix, which is 4, 1, 8, 0, 1, 3, 10 minus 9, 4. And then the last one, 4x4 matrix. You can start with any number. This is a -2. And we have 3, 1, 5, 8, 7, 1, or 7, 9, 2, 4. Then 6, 11, minus 3, and 2. That's called a 4x4 matrix. 4 rows and 4 columns. Okay, by now you should be able to give examples of 2x2 3 by 2, 3 by 3, and 4 by 4 matrix. Okay. Then we move on to addition and subtraction of matrix. Just like you add numbers, you can also multiply, you can also add and subtract matrix. I said we can add and subtract matrix. We can add 2 by 2 matrix. We can add 3 by 3 matrix. And we can also add 4 by 4 matrix. You can only add and subtract matrix with the same rows and columns. That's why I said we can add 2 by 2, 3 by 3, and 4 by 4. You cannot add 3 by 2, but you can multiply 3 by 2. So you can only add matrix with the same rows and columns. Example, under addition and subtraction of matrix. Given example 1, given A equal to 2, 3, 1, 5, and B equal to 5, 1, 3, 4. Find A plus B and also A minus B. We want to find A plus B and A minus B. Okay, you can see it on the board that we have a 2 by 2 matrix. Therefore, we bring it down. A plus B is 2, 3, 1, 5 plus 5, 3, 1, 4. Our lesson was matrices. And I said that matrix is a set of numbers that is arranged in rows and columns to form a rectangular array. And I told you that we have some examples under matrix, like a 2 by 2 matrix, a 3 by 3 matrix, a 4 by 4 matrix, 3 by 2 matrix, and others. And I went on to say that we can add and subtract matrix. And you can only do this if they have similar rows and columns. In other words, you can add matrix that have 2 rows and 2 columns with another one that has 2 rows and 2 columns. You cannot add 2 rows and 2 columns with 3 rows and 2 columns. So it has to be similar. Then we can also subtract matrix with similar rows and columns. So I wrote one example here on the board. That given A equal to 2, 3, 1, 5, and B equal to 5, 3, 1, 4. We have to find the addition of A and B, and also subtract B from A. Okay, so A plus B. You pick the first number on the first row, add it with the first number on the first row. That is 2 plus 5. Pick the second number on the first row, add it with the second number on the first row. 3 plus 3. The same thing with the second row. And that gave us 7, 6, 2, 9 as A plus B. Now we want to solve for A minus B. In other words, we want to subtract matrix B from matrix A. So this is done as 5 minus 4, 1. Therefore, we have minus 3 and 0 on the first row, 0 and 1 on the second row. That is A minus B. Remember, you will only add or subtract if they are similar. If they are not, you cannot add, but you can multiply. So we move on to multiplication of matrix. If, for instance, you are given A to be 315 and B to be 203, find A dot B. A dot B simply means A times B, because dots in mathematics is also multiplication. So what can you say about these two matrices? What kind of example is that? Or what kind of matrix is that? That's a 1 by 1 matrix. Okay. So matrix A is 315. So A dot B equal to 315 times 20. Sorry, this is, let me change this to only one row. Not one column, one row. 203. So we want to multiply this. We simply say, remember, you can multiply with matrices that don't have similar rows and columns. So we simply say the first number on the row or on the column times the first number on the row. That will give us 3 times 2. 3 times 2. Since it's multiplication, we join them together, because in multiplication you must have one particular answer. And since it's a 1 by 1 matrix, we can bring them together. Or sorry, 3 by 1 matrix, we can bring them together. And this is 1 plus 1 times 0. And then plus 5 times 3. And I'm multiplying 3. No, we are still sorry for the network interruption. We were trying to find A dot B as A times B, matrix A times matrix B. And matrix A is given as 315, while B is 203. That's one column and one row. So we simply multiply 3 times 2 plus 1 times 0 plus 5 times 3. And that gave us 6 plus 0 plus 15. And our final answer is what? Sorry, our final answer is 21. That's 6 plus 15. I want you to check your notes. If you have any question, you can ask before we move on to another subtopic under matrix. We are going to look at transpose of a matrix. Transpose of a matrix. To transpose a matrix simply means to change its rows into columns and columns into rows. And it is denoted as a matrix raised to small or raised to capital letter T. If A is a matrix and you have to find a transpose of A, it is written as this. Example. Given that matrix B is 5, 1, 6, 5, 1, 6, or rather, let me give you a 2 by 2 matrix, 4, 3. And you have to find B transpose. It simply means you should change the rows to columns and columns to rows. So that becomes That becomes 5, 1, 4, 3. You can see it on the board. 5, 1, 4, 3. The first row has been changed into the first column. The second row now interchanged to our second column. So it's simply the changing of rows to columns. Let us solve one example under this. If you can take this as example 2. If A is 276, 315. I picked this question from one of your WAEC past questions. That is why I'm copying it directly from the past question. And B equal to 4037 15. The first question is to find A dot B as I, and II B transpose. A dot B transpose. Solution. We simply bring down our matrix. A dot B as 2, 7, 6, 3, 1, 5. What kind of matrix is this? It's a 2 by 3 matrix, 2 rows, 3 columns, multiplied with 4, 0, 3, 7, and 1, 5. We want to multiply these two matrices together. So we are going to use the first row and multiply with the first column. Also use the first row, multiply with the second column. Then we move on to the second row. Use the second row to multiply with the first column, and also use the second row to multiply with the second column. So that will give us 2 times the first number times 4 plus, when dealing with multiplication, plus 7 times 3 plus 6 times 1. Now we are done with the first number or the first row, or the first number on the first row. Then we pick the first row again to multiply with the second column. 2 times 4 plus 7 times, 2 times 0, because we are using this to multiply with this. 2 times 0 plus 7 times 7 plus 6 times 5. I said we use the number on the first row to multiply with the number on the first column. We have done that. Also use the first row to multiply with the second column. Okay, so we move to the second row where we have 3, 1, 5. So we pick the first number, which is what? 3. To multiply with 4. 3 times 4 plus 1 times 3 plus 5 times 1. We had the same thing with the second column. 3 times 0 plus 1 times 7 plus 5 times 5. Let me clean this upper part. Two times 4 is what? 8 plus 7 times 3, 21 plus 6 times 1 and 6. And the second part we have 2 times 0, which is 0 plus 7 times 7, 49 plus 6 times 5, that is 30 as our first row. The second row is times 4, 12, plus 1 times 3, 3, plus 5 times 1, 5. We move to the second part. 3 times 0, 0, plus 1 times 7, 7, plus 5 times 5, that is 25. So let us add up all the numbers. 8 plus 21 is what? 29, plus 6, 35. So the first number on the first row is 35. The second number on the first row is what? 0 plus 49 plus 30. I think that is 79. So our first row is 35 and 79. The second row, 12 plus 3, 15, plus 5, 20. Then 0 plus 7 plus 25, that's 2. So our A dot B is 35 and 79 on the first row, 20 and 32 on the second row. So we have 2 rows and 2 columns. Then for A dot B transpose, remember I said to transpose a matrix simply means to turn the rows to columns and columns to rows. A dot B transpose equal to 35. The rows now turn into columns and 20. So that's our A dot B transpose. Before I hand over to my colleague, we'd like to remind ourselves again, or maybe go back to the meaning of matrices. I said matrix is a set of numbers that is arranged in rows and columns to form a rectangle array. And then we can add matrix and subtract matrix with similar rows and columns. We can also multiply matrix. We can find the transpose of a matrix. In our next class, we are going to find the determinants of matrix. So as you stay at home, make sure you open any textbook where you have determinants of a matrix. In our next class, we are going to find the determinants of a 2x2 matrix and 3x3 matrix. So have a nice day and wait for the next lesson, which is chemistry.